So hello everyone, welcome back to my YouTube channel. So now we'll be starting with competitive programming. Now we have started with data structures and algorithm, design and analysis of algorithms. So along with that, let's start with CP also because that's basically a continuation of these subjects. So let's start. First, let us see what is STL, Standard Template Library. It is a library in C++ that provides ready-made data structures and algorithms. So it helps avoid writing data structures from scratch. The main components are containers, algorithms, and iterators. Containers store the data. Containers store the data. Algorithms do operation on the data, and iterators are used to traverse the containers. Let's understand with the help of example. You have a bag full of balls. This bag is a container. Algorithm is that you have to pick one ball from the bag and place it into this basket. You have to place it in this basket. Now, what is the iterator here? Your iterator will be your hand that will traverse through the bag and pick a ball and place it in the bag. So this is what is standard template library. Next, let's see what is vector. A vector is a form of a dynamic array. We've seen an array like A, B, C, D, and so on. This is basically an array. Now, what is the difference from a normal array that we have seen? That its size can grow automatically and memory is handled internally. Now, let's understand some functions. This is an example, but first of all, we need to know about the functions associated. Now, first is push underscore back. That adds an element. Pop underscore back removes last element. Size gives the number of elements that are present in our vector. Empty function is used to check if the vector is empty or not. This is an example given on the left hand side for you all to refer to. Next, we have pair. A pair stores two values together. It is useful when storing related data. Example, pair of int comma int p. Let's suppose you want to store the x and y coordinates in mathematics. How will you do that in coding? It can be done either using pair or using map. With C map, in pair we create a pair like this 5, 10. P dot first, P dot second is used to access them. This will be your P dot first. This will be your P dot second. Coordinates X and Y. The similar example that we had taken. Now let's see map. A map stores key value pair. Like number 1 has 2 occurrences, number 2 has 8 occurrences, number 3 has 9 occurrences, number 4 has 1 occurrence. Now, when you have to compute the maximum count, max count is for which element? It will be easy in this case. You have to only compare the second parts of each of the map to get the key part. Now your max count here is 9. 9 associates to 3. Now let's suppose we take roll number is 2 marks. You take a map MP of 1. So suppose you write MP of key is equal to value. Keys are unique and are sorted automatically order of log n time. How do you trade for auto X? For auto, x is to map, then x dot first and second, like in the case of pair, dot second. So are you able to understand the difference? Here you are storing two correlated values that you will have to use. But here you can use values that may or may not be correlated, but one can be used to get the other value or the answer. Now let's start with unordered map. Unordered map is same as map, but here it is not sorted. Very important point. It uses the concept of a hash table. How do you write it? Unordered underscore map int comma int map. Now it is faster. It has average time of or constant average time. And disadvantage is that it is not has any ordering. So we basically all have to compare again and again. This is for nominal categories. A set stores unique elements in sorted order. Let's suppose we have different elements. It will store them in sorted order. Suppose here they give to 5 to 5. It will take 5. Then when you have to insert 2, it will do 2 comma 5. Then again 5, so no change. So duplicates are ignored. It is useful when you need unique and sorted values. So unique and sorted value. Multiset is same as set but allows duplicates. That means it is allows duplicates and have sorted values. Now, one more thing that you all should know, it is not important to again write hashtag include IOStream, then you write hashtag include set, and so on. It will become a very tedious task for you all. So what you do is you write hashtag include bits slash stdc++ dot h. Standard template library. It has basically all these set, map. So you lot have to put them as a header file again and again. Next, let's see stack. Stack follows a LIFO order, last in, first out. Queue uses FIFO order. So basically in stack, like you can see the diagram that I've drawn, we push 1, then 2, and then 3, like a stack of books. Now the book on the top will be the last book that you have kept in the pile. That is 3. So when you'll pop it, 3 will first of all come out. And similarly, like I've shown in the example below, you push 10, you push 20, and when you ask for top, you put the or you give out the topmost book. In queue, you use first in, first out. 1 enters, 2 enters, and then 3 enters. When you have to remove, first of all, 1 goes, you are left with 2 and 3, and then 2 goes, you are left with 3, and then 3 goes, you are left with the empty array. Basically, when you push 1 comma 2, 1 goes, 2 left, then 2 goes, and array is empty. Next, we have priority queue. Priority queue always returns the largest element first. Insert 5, 1, 10. Top will be 10. So this is the code. If you ask me what is this and what is this, this is the statement for your max heap. When you normally use priority queue, it's generally referring to a max heap. When you use a min heap, usage of vector int and greater int is necessary. This is very important. In the question, it may or may not be specifically written which heap you have to use. But based on the question, you have to identify. Like suppose I give you a question, you have to find the maximum SIM that receive the maximum number of calls within a time frame of 30 days. Maximum phone call. What do you think? Which one should be used? Min heap. Min heap means all the maximum will be at the root. Max heap means you'll get the highest at the top. I think max heap will be the best one here because you need to know the SIM that receive the maximum calls. Now, important STL algorithms. First is lower underscore bound. It returns the first element greater than or equal to the target. 1, 3, 5, 7, 4. What do you think? 1 is greater than equal to 4? No. 3 is greater than equal to 4? No. 5 is greater than equal to 4? Yes. And this is the first element. So this will be the lower underscore bound. Upper underscore bound gives the first element greater than target. 1, 3, 5, 7. 1 is greater than 5? No. 3 is greater than 5? No. 5 is greater than 5? No. 7 is greater than 5? Yes. Your answer will be 7. Max or minimum returns the largest or the smallest element. Max underscore element or min underscore element. Now, a memset is used to initialize arrays. Memset array start end. This sets all the elements to 0, 0 value. Example, this is the example what will be generated. Suppose you have a size as 4. Comparators. Comparators control how sorting happens. Default sorting is ascending. Let's see a custom comparator in descending order. Bool compare int AB. You have to check if return if A is greater than B. This is for a descending order. And then you sort it. When you have to use ascending order, it's simple. What you all do is, suppose let's say vector is v dot begin, comma v dot end. Simple. And you get the sorted array or vector. Here you have to do it in descending order. So we'll have to use comparators. Array techniques. These techniques help solve problem in order of n time. Big O of n instead of big O of n square. Two pointer technique is used when your array is sorted. That is find two numbers whose sum is equal to target. Now one pointer at start and one at your end are rare. Now you have to see, suppose you have 1, 2, 4, 6, 8. One pointer here, one pointer here. Target is 10. So 1 plus 8, 2 plus 8, 4 plus 8, 6 plus 8. Similarly, it will be checked. In this case, you found it at the second step itself. So what will be the code? One is at start 0 index, one is at n minus 1 index, till your left is less than your right. If the sum is equal to target, break it. Else, if your sum is less than your target, if it is less than your target, let's see. If it is less than your target, that means your target would be somewhere around the right hand side. So L plus plus. So now your L will go here. Similarly, if it is greater than your target, that means your value would be smaller. So you have to move to the left hand side. Your time complexity will be big O of n. Next is your sliding window. It is used for sub-array problems. Instead of recomputing the sum every time, we adjust the window. Example, we find the sum of every subarray of size k. Normal approach, we get the time complexity of n into k, but by sliding window, we get the complexity of n. Now let's suppose we calculate the sum first. Then we put the loop from k to n. Sum will be plus equal to your a of I, while you'll also be subtracting it from the end. I is equal to k to n. So this is what is happening. So let's suppose your k is equal to 4. Size is equal to 8. That means after every 4 times, you'll have to check again and again. Or we'll have to form the window here. So that is what is happening. Now this is Kadane's algorithm. It is used to find the maximum sub-array size. Let's suppose you have an array. Maximum sub-array is this and your sum will be 6. If current sum becomes negative, you reset it. That is the algorithm idea behind. Max sum is equal to int underscore min. Current is equal to 0. From I is equal to 0 to n, current plus equal to a of I. Your maximum will be your maximum of a current and your maximum, because if current has a negative value added to itself, that means the sum in current will get reduced. We want the maximum sum. And if your current is less than 0, assume it to be 0. Next we have prefix sum. It is used for fast range sum queries. You have example array of 2, 4, 6, 8. Prefix arrays 2, 6, 12, 20. Prefix of I means sum of the first I elements. If we say prefix of 0, that means sum till the first 0 element, that will be suppose 1, 3, 5, 7, 9. So 1 will be the answer. For I and M, prefix of I minus 1 plus A of I. Sum till the last element incurred plus the current element. You need to remember this very important formula. Range sum is equal to prefix of right minus prefix of left minus 1. Binary search works on sorted arrays. We have covered binary search. Derive your search space into half at each square, mid L plus R by 2. If your a middle element is equal to your target, you return the middle element. If it is less, then you know that it will be, suppose this is, let's say, your left, your mid, your right. If it is less than your target, that means it will lie in this range. Therefore, your starting index will become mid plus 1. This will be the change. If it is less, that means it will lie in this range. L remains the same, but R now becomes mid minus 1. So this is what is implemented here with log n time complexity. Now we'll be starting with number theory. Number theory, we have GCD LCM. GCD of 12 and 18 is 6, and this is the code. It is double underscore GCD of A comma B. LCM is equal to A into B divided by GCD of A by A comma B. Very important formula. Binary exponential is used to compute A to the power B quickly. Normal method, binary exponential. Long power, long A, long B. Assume if it's confusing, LL. You write hashtag define LL long, and then you write the code. You can use LL instead of long. If, let's say result is equal to 1. If your B is greater than 0, use this operator, AND operator. Res into equal to A. A into equal to A and B left shift equal to 1, and you return the result. This is what binary exponential. Then we have sieve of Eratosthenes. It is used to find all prime numbers up to n. Here we use bool prime, a prime Boolean array of n plus 1 size. Then we use memset to initialize the array with true value. From 2, like we use in prime, if prime of I, then if not, return false. This is basically the concept. I'll erase this. So this is basically the concept. Now, an interesting topic, bit manipulation. Bitwise operations work on binary representation of numbers. This symbol represents AND. This represents XOR. This represents NOT. Left shift and right shift. To check if a number is odd, n and 1. Now, if it is not odd, you'll just perform NOT. To check even, ith check ith bit, set ith bit, remove ith bit. To check ith bit, this is the condition. To set the ith bit, this is the condition. If you can see, check, set, and remove. It is almost the same. Remove. So now next, we have XOR property. Now in XOR, a very important thing is same gives 0 and different gives A, or whatever variable you want to. This is super important and used in your lab questions. This is for finding single element in an array and also used for swapping numbers. Left shift and right shift. Left shift. Here we apply the concept of multiply by 2. In right shift, the concept of divide by 2. I provided examples also for your reference. These will be helpful in understanding this concept of multiply and divide. Now, if you want to check if it is even and odd, we right now had seen this. You are able to solve the whole question just if you remember the things that I discussed earlier. Check if a number is power of 2. Very common question. Power of 2 has only one bit set. Therefore, you apply the condition of n greater than equal to n greater than 0 and your n and n minus 1. Next, now count the number of set bits, or one, like we had seen in the earlier part just before this. Method 1 is loop. Count is equal to 0, count plus equal to n, and there we had seen n greater than 0 and n minus 1. This is what we have seen. Now let's see an alternative way if we have any. Count plus equal to n and 1, and then you do right shift. Now this is a built-in method. You can use this if you remember. This is double underscore built-in underscore pop count n. Finding unique element. Every element appears twice except one. Use XOR. Why not XOR? In XOR, if you get your answer as 0, that means you have identified the element that is same. XOR cancels the duplicates. Set, unset, toggle. Very important. Set we have discussed. Unset, use the not. And in toggle, I write toggle. Use XOR. Now, XOR for range queries, this is an advanced part, but it is asked. If you want XOR from 1 to n, you can use this table. This is a common competitive trick. So thank you all. This was all for today's video where we discussed different topics, and these topics form the basics of competitive programming. Right now, we have a huge variety of questions that are based on these topics, but you may not find a question that is completely based on what we have studied today. It may be a mix and match where you have to use comparators along with an algorithm. So, thank you all. If you have any doubts, do mention it in the comment section. If you like the video, do like, share, comment, and subscribe to my channel. Thank you. Bye bye.